Welcome back to my channel. This is Jumana Khanfar from Taqarub International Schools. Today we're gonna study functions transformations. Transformations of functions include translation. Translation means to shift the function up or down, right or left. An up or down shift is called vertical shift, and a right or left shift is called horizontal shift. Then we'll study dilation. Dilation means to stretch or to compress the function when you multiply x or y by a factor. Reflection is when you multiply x or y by a negative sign. This leads to a reflection in the x-axis or the y-axis. Now we're going to study all of these cases one by one. Translation is when the function is shifted up or down, a vertical shift, right or left, a horizontal shift. Suppose y equals f of x equals e to the power of x. This is the parent function before the transformations. Describe the graph of y equals e to the power of x plus 3. Now when we add 3 to the whole function to the value of y, all the values on the graph will be shifted up 3 units. Here, this point is 0 and 1. It's gonna be 0 and 4. For example, if this point is about 2 and 8, it will be 2 and 11. Because all the y values are shifted up. But sometimes we use key points because it's easier to determine their location, like the y-intercept. So for example, if y equals 3x, this is the parent function, y equals 3x plus 1 will be shifted up 1 unit. Now what about this function here? The parent function is the same as the previous one, but here the new function is e to the power of x minus 3. This will shift the function down 3 units. Look at this point. Here it is 0 and 1, and it became 0 and negative 2. 1 minus 3 is negative 2. So this point is shifted down 3 units. Actually, all the points will be shifted down 3 units. But as we said, it's easier to determine the shift for the y-intercept. Now, what about this example? The parent function is the same, e to the power of x. Describe the graph of y equals e to the power of x plus 3. Here we changed the value of x, not the whole function. We didn't add 3 to the whole function. We added 3 just to x. So this is a horizontal shift. When you add a number, the function shifts to the left. When you subtract a number, the function shifts to the right. Suppose that x is 0 here. It will be the same value of y for x negative 3 because negative 3 plus 3 is 0. That's why it's a horizontal shift to the left, not to the right. So when you add a number, it's shifted to the left, and when you subtract a number, it's shifted to the right. Let's see this point here. This is 0 and 1, the y-intercept. The value of y stays the same, but the value of x decreases by 3. It's going to be shifted to the left by 3. So it's going to be negative 3 and 1. So the value of x decreases by 3. Also, if it has minus 3 here, e to the power of x minus 3, it's going to be shifted to the right by 3, and this point will be 3 and 1. The graph will be somehow like this. Now let's study the translations on a quadratic function. Y equals x squared. Y equals x plus 1 squared. Here we change the value of x by adding 1. Now y equals x squared plus 1. We add 1 to the value of y, to the whole function. So here it's a vertical shift. In this case, it's a horizontal shift to the left. Let's see this on the graphing calculator. This is the graph of y equals x squared. The vertex is at 0, 0. It opens up Let's see these points for example. This is 2 and 4, and this is -2 and 4, because 2 squared is 4 and -2 squared is 4 as well. Now let's see what transformations are made by the other functions. X plus 1 all squared. We expected that this will shift the function to the left by 1 unit. The blue one is the new function. Look at this point. This is 0 and 0 here, and this point for the new function is -1 and 0. So the value of x is decreased by 1. It means that the function is shifted to the left by 1. Let's see all the points. For example, this point here, this is 1 and 1. Here it is 0 and 1. So the value of x decreased by 1. And it's applicable for all the points on the graph, as we said. But we choose some key points because their location is easier to be determined. Now let's graph this one. We expect that the graph of this function will be the graph of x squared, but shifted up by 1 unit. The orange graph is the new one. This point is 0 and 0, while this point here is 0 and 1. So the value of x is the same, while the value of y increased by 1, and it's the same for all the points. For example, here this is 1 and 1. This point is 1 and 2. So here for this case, the function is shifted to the left by 1 because we added 1 to the value of x. Here we added 1 to the value of y, the whole function, so it is shifted up. The value of y is changed here, while the value of x is changed in this case. The other type of transformations on functions is the dilation. The dilation is when you multiply x or y by a number. So you stretch or compress the function. This is the parent function, y equals x minus 1 all squared. Now this is y equals 3 times x minus 1 all squared. This function here is 3 times the parent function. The value of y is multiplied by 3. So we expect that y will be 3 times bigger than the original one. Let's apply it for different numbers. Let's say that x is 2 and 3, for example. Now, we will substitute in y1 and y2. When I substitute 2 for x here, 2 minus 1 is 1, 1 squared is 1. And for this function, 2 minus 1 is 1, squared is 1 as well, times 3, this is 3. So it is multiplied by 3, so it is stretched by 3, by a factor of 3. Let's try it for the 3. 3 minus 1 is 2, 2 squared is 4. I expect that it will be 3 times bigger, so this is gonna be 12. Let's try if it's 12 or not. 3 minus 1 is 2, 2 squared is 4. 4 times 3 is 12. So yes, it is stretched by a factor of 3. Let's see the graph of y1 and y2 and compare them. This is the graph of y1, while this is the graph of y2. It's stretched vertically by a factor of 3. For example, this point is 0 and 1. Here it is 0 and 3. So the values of y are multiplied by 3. This is almost negative 0.4 and about 2. What about the point here? It's going to be negative 0.4 and 6. So it's multiplied by 3. The value of y is multiplied by 3. It's easier to be determined for the y-intercepts. Now for y3, we will try the same numbers, but for y3. For x equals 2, 2 minus 1 is 1, squared is 1. 1 times 1 over 3 is 1 over 3. Now for 3, x equals 3. 3 minus 1 is 2, 2 squared is 4. 4 times 1 over 3 or 4 over 3. the value of y decreased by a factor of 3. It's like dividing the y values by 3. The values of y will be 3 times smaller. So if the parent function is somehow like this, y3 will be compressed because the values of y are 3 times smaller. The green one is y1, the parent function, while the orange one is y3, which is 1 over 3 times x minus 1 all squared. For example, if we compare these 2 points, this is 0 and 1, here it is 0 and 1 over 3. So the value of y is 3 times smaller. Now what if we multiply x by a factor? In the previous cases we got a vertical dilation, like the value of y decreased or increased. But here we will get a horizontal dilation. The value of x will be affected. Let's see the graph of this one to understand the transformations done on the parent function. This is y1, this is y2, and this is y3. Now this is y1, x minus 1 squared, and this is y2, 3x minus 1 all squared. You can see here that the value of x decreased by a factor of 3. So this is a horizontal compression. Actually it looks like a vertical stretching also, but actually it is because of a change in the x values in the midterm. So these are the values of x for both of them. It is compressed by a factor of 3. So when x is multiplied by a factor that is greater than 1, let's say this is a is greater than 1, then the function will be horizontally compressed by a factor of a. Now, what about this one? What do you expect? A is less than 1. A is 1 over 3. 1 over 3 is less than 1. This is the opposite. So we expect that the function will be stretched horizontally. Let's see this on the graph to prove our assumption. The green one is y1, while the orange is y3. So we see that it is stretched horizontally by a factor of 3. For example, this is 1 and 0. This point is 3 and 0. So the value of x is 3 times bigger. We conclude that for the horizontal dilation, when x is multiplied by a factor greater than 1, it will be compressed horizontally. When x is multiplied by a factor less than 1, it will be stretched horizontally. Now, the reflection is the easiest type of transformations. Actually, when you multiply a function by a negative, it will be reflected either in the x-axis or in the y-axis. For example, this is the parent function, y equals e to the power of x. This is y2 and this is y3. y2 is negative e to the power of x, so y1 is multiplied by a negative. So the y values will be multiplied by negative. Let's try that for x equals 2 and x equals 4, for example. This is y1 and this is y2 and this is y3. E to the power of 2 is, by the way, E is Euler's number. It is about 2.72. You find it in your calculator as E. E squared is about 7.4, while e to the power of 4 is about 54.6. Now y2 is negative 7.4 because it is negative e squared, and here it is negative 54.6. So all the y values will be reflected vertically in the x-axis. So instead of having 7.4, we will have negative 7.4, and instead of having 54.6, we will have negative 54.6. The green one is the parent function, it's e to the power of x, and this is negative e to the power of x. We see that the values of y are reflected. When x is 0, y is equal to 1, but for the other function, when x is 0, y is negative 1. Here, when x is about 1.4, y is equal to 4. But the reflection of this point down is this point when x is about 1.4, y is about negative 4. So it has the same value of y, but negative. This is what we call reflection in the x-axis. Imagine that you have a mirror here on the x-axis. All the values up will be reflected down. Now, if we multiply the value of x by a negative number, it will be reflected in the horizontal direction, in the y-axis, like I will imagine a mirror on the y-axis. Now, let's apply this for y3. E to the power of negative 2 for x equals 2. This is equal to, it's about 0.14, which is actually 1 over e squared, because this is e squared. Now, what about e to the power of negative 4 when x is 4? It's much smaller. It has 0.018, because this is 1 over e to the power of 4. We know that when the exponent is negative, we move it down to make it positive. Let's see the graph of y3. This is e to the power of x, and this is e to the power of negative x. It has the same shape of the graph, but reflected horizontally, reflected in the y-axis. If I imagine that there is a mirror here on the y-axis, I see that they are reflection of each other, or the function is horizontally reflected. For example, this point is 1.4 and 4.05. This point is negative 1.4 and 4.05, around that number. So the value of x is reflected, multiplied by a negative sign. I conclude that when I multiply y, or the whole function, by a negative sign, the function will be reflected in the x-axis, or reflected vertically. When I multiply x by negative, the function will be reflected horizontally, or reflected in the y-axis. This is a question for you. You need to solve it to test your understanding of reflection. Send it to me on Class Dojo or put the answer in the comments below. In the next video, we will study the symmetry of even and odd functions. Thanks for watching.